Hello student, look at this question. Let us solve this question. Is saying that a symmetrical star-shaped conducting loop wire loop is carrying a steady current I is shown in the figure. The distance between diametrically opposite vertices is 4a is given 4a. So he is asking magnitude of the magnetic field at the center of the loop. So at the center of the loop he is asking magnetic field. So this question is purely based on a Biot-Savart law application, and this question has asked in JEE Advanced. Okay, so let us solve this question. Okay, so now look at here. So before solving this question, try to understand how many vertices are there. Okay, so let us give numbering also. 1, 2, 3, 4, 5, 6. 6 vertices are there. And another one is given some idea that the 1 and 4, which means two diametrically opposite points which are at a far of 4a. So you can take from 1 to the center. Okay, how much it is? It will be 2a then. Okay, then this also 2a, total 4a. And one more thing, try to understand about this structure. If at the center, at this center, total angle how much? 360. You know this, in a loop total angle is 360. So each vertex how much angle will be having, that is what we are going to calculate. So how many vertices are there? 6 vertices are there. So how much every vertex angle will be there? 60 degree, right? It will be 60 degree. So which means every vertices will be 60 degree. Okay, and when I draw a line which bisect this vertex 60 degree in middle, then how much angle this will be? 30 degree. I hope you understood. This angle will be 30 degree. Just a minute. This angle will be 30 degree. Okay. Now similarly I can draw, there is another line from here to here. Okay. I can draw another line here. Okay. So it is not came straight. Okay. One second. Okay. Fine. So this is also 30 degree. This is also 30 degree. Now try to understand this question. First, what is the formula for this question? So in Biot-Savart law application, we do this formula: magnetic field at the center, mu naught by 4 pi I by R. R should be perpendicular, that we know that. Sine alpha plus sine beta. This is the formula where we apply. There is a wire carrying current I, and you are going to find magnetic field at this point, which is at a distance of R. So this is your angle from here is alpha, angle from here is beta. Okay, and remember that here if alpha arrow mark is upward, then alpha is positive. If beta arrow mark downward, then beta is positive. Okay, if beta is if the arrow mark is reverse, then you have to take negative. Okay, so the sign. Yeah. So now on the same formula we will apply here. So try to understand here. So when I do this here, I know this angle, I know this angle 30, but I don't know what is the angle made here. So when you try to understand this, so you do one thing. You take this wire to straight. You just take this wire to straight. Okay. So you see here how much angle here. You see this line is a perpendicular to this line, right? 90 degree, right? So you can see here that okay, you can see here this one I am saying. So try to understand here. Yeah, 1 second now. Not coming straight. Yeah, it's going like a snake motion. Okay. So this is 30 degree. This is 90 degree. Right? You drawn a line which is 90 degree. So you see here that this one is a right angle triangle. One, this one, and O. You can say center O. Okay. One dash O. Okay. This is a right angle triangle. So if it is 19, this is 30. This is how much, ma? this will be 60. Okay, this will be 60 angle. So let me write here, this will be this arrow mark here, I will write here 60. Okay, this arrow mark here I will write. Otherwise let me write here next to arrow mark 60. Okay, and I am, and one more thing, I was calculating only the magnetic field due to this wire, which means one this wire. Okay, so as you see in this file, that you have to know alpha beta are the angle from the upper edge, I mean upper end to the lower end of a one wire. So when you take in this wire, this is one end and this is another end. Okay, so another wire, another line you draw here, and to the another end. Okay, so how much angle does this end makes, that is your question, how much angle this end. So you know this, if it is 60, this will be how much angle this will be, 30, this will be 30 angle here. So you can see from here that your diagram shows like this to you. So this is 90, otherwise let me check here, so which is we have drawn here. Okay, so this will be how much, 60, let me draw here, this will be 60 and this will be 30. Okay, this will be 30, this is the end 1, this is end 2. And one more thing, you need to know this r perpendicular, because you know you should this is not a r, this is the which is not a r perpendicular, this is the perpendicular, okay, to the wire. So this is the r for this wire, this is the r perpendicular, you need to know that. And you know this is a 2a, right? So from this right angle triangle, from this right angle triangle, you can see this, from this right angle triangle, what is your r perpendicular, which means uh, 2a cos, how much angle for this right angle triangle, 60. So r perpendicular equal to 2a cos 61 by 2. So which means which is a, r perpendicular equal to a. Now if I substitute here, so in my formula p equal to mu naught by 4 pi I by how much current is flowing, I by r perpendicular a, sine first angle alpha is, what is this angle, 60, another angle is plus sine 30. Now listen my here, I told you in before case that these sign conventions are very important. Okay, but if you see here that sine 60 also positive, if you see here 60 also positive, sine 30 also in the same direction. So we will take this sine 30 as a negative symbol, because we will actually need to take this is reverse direction, but it is we have to take like this, but the situation not like that, so we have to take in this. So since direction is reverse, we have to take here minus. Okay, hope you understood this one. Okay, so I will take here minus symbol. Okay, we'll take here minus symbol. So now if I substitute here, what will come, mu naught by 4 pi I by a, sin 60 is root 3 by 2, sin 30 is 1 by 2. So total mu naught I by 4 pi a root 3 minus 1 by 2. This is the magnetic field due to one segment, one segment, one segment. So how many segments you are having? One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Total 12 segments are there. So which means the total magnetic field will be 12 into V1. So if you do that, how much will come? 12 mu naught I by 4 pi a root 3 minus 1 by 2. 2 6 are 12. So your answer is mu naught by I by 4 pi a 6 into root 3 minus 1. I hope you understood this. And if you go back to this here, which option will be correct? Option 1. And one more thing that you need to know about the direction of the magnetic field. So you can use right hand thumb rule to denote the direction of the magnetic field. In all the segment, one more thing I have done here, uh, before doing this B total at the center, you have to know the direction. All the segment are magnetic field at the center, same direction or not. For that, right hand thumb rule you have to use. So if you check here, magnetic field here, this will be inward, here this side will be outward for this segment. For this segment, here inward, inside, outward. Okay. So for all the segment, magnetic field similarly, because symmetric structure is there, inside will be outward. So your final magnetic field will be, it here will be outward. Okay. Your magnetic field is outward. Thank you. If you like this explanation, please share and subscribe to this channel. Thank you.